team. Let's have a look at the final question from your prelim exam. We have a diagram that shows part of the curve that has this equation here, y is equal to x cubed minus 2bx squared plus b squared x. We also have a line OA, so it goes from the origin to this point A, which is the maximum point of the curve that we've already described in the highlighted yellow. The x coordinate of A is little a, and the curve has a minimum point at B, over there, and B comma 0, where A and B are positive constants. So we have to show that B is equal to 3A. Now, to do this, I'm going to differentiate the function to find the gradient function, because both A and B are turning points, so I know that the gradient there is 0, and I'm having to show something about B, so I'm pretty sure I'm going to need the gradient function. So I would write dy dx is equal to 3x squared minus 4bx plus b squared, because the a and b are constants, so just pay attention to that. It's dy dx we're doing here. Okay, now I also know that I can set this to 0 to find the minimum and maximum points. And I could use the quadratic equation like this. Minus 4 times A times C all over 2 times A. And this would simplify to 4B plus or minus the square root of 16b squared minus 12b squared all over 6, and that would give me 4b plus or minus the square root of 4b squared all over 6, and that would give me 4b plus or minus 2b all over 6. Now, there are so this will give me the x coordinates of the two turning points. Now, the smaller turning point is turning point A, which would be 4b minus 2b, so that would be 1/3 b. And the other turning point is going to occur when we've got 6b over 6, which is b. And that means, therefore, A times 3 equals B, because this one here, this x value, and perhaps I should have written x equals here, is that one there, and this one here is that turning point there. Well, I hope that makes sense to you. Let's take a look at this next part of the question. Alright team, so the second part of our question is that we've got to show the shaded region. So we're looking at this little bit here, and it's between the line and the curve, and we know that it's Ka to the 4, where K is a fraction to be found. Now immediately we know that we're using integration, but since we've got this here, A to the 4, I think we need to rewrite this equation here in terms of A given what we found here. So I say we can write y is equal to, and then we can write it as x cubed. And then the next bit would be minus, now b is 3a, so that would be minus 6a x to this x to the 2 plus, and we know that b squared is going to be 3a squared, so that would be 9a squared x. So this would be my first thing, and the reason I do that is because I know that I need my answer is Ka to the 4. And now, integration. To get that shaded region, the area is clearly going to be the integral of what I've just written, x cubed minus 6ax squared plus 9a squared x dx minus the area of the triangle, which is half times a times the height. Now we could probably figure that out. So I'm looking at this triangle here. The height of that triangle we're going to say is a cubed. I'm putting in this x value here, minus 2 times 3a, which is b, times a squared plus, now b squared, that would be again 3a, so 9a squared times a. So should be 10a cubed minus 6a cubed equals 4a cubed. So this is the height. All I've done to get that is stick in a to all of the x values, and all of the b values I substituted also for a using this formula down here. So the height of the triangle is 4a cubed. Now let's take this second line here. This is going to be 1/4 x to the 4 minus 6a, whoops, not minus 6a, minus 2a x to the 3 plus 9a squared x squared over 2. And of course I should have put my limits in before. I'm going between 0 and a. Then I would subtract that by, now what does this look like? Half times 4 is 2, so 2a to the 4. Now let's work this out. Chuck in our a value, our upper limit. So it should be 1/4 a to the 4 minus 2a to the 4. I'm just substituting in a for all of the x's, plus 9a to the 4 over 2. Then when I stick in my zeros as my lower limits, I get 0. So let's see what this gives us. I'm going to turn them all into quarters. So 9 halves is 18 quarters. So I've got 19 quarters, and then I'm going to take away 8 quarters. So this should give me 11/4 a to the 4, subtract 2a to the 4. Okay, so all of this here adds to 11 quarters. And that should give me a final answer of 3/4 a to the power of 4. and I have completed that question. Well, I hope that makes sense. Don't hesitate to ask for further details or more clarification if necessary. All right, take care.